My question is, if you have a function f(x) and you have a function f inverse x, if they intersect, they will only intersect on the line y equals to x. Is that a right statement or wrong statement? And I give you a question to think about. Fx equals to square root 1 minus x. I ask you to find the inverse and then discover the point of intersection or point of intersections on this graph. Okay, anyone has tried this one or not? Anyone try what you discovered? Do you think the statement is the right statement first?
Yeah.
So if anyone find the intersection for this graph, what's the intersection? Anyone work out the intersection? Anyone actually do it? What's the intersection? It's a quite complex number. Maybe you don't get it wrong. Like it's a third, like 1 minus root 5 or something. It's a quite complex number.
No, I didn't get it. It's okay. Just carry on the lesson.
Okay, so then let's have a think about this question. I just open another page. Also go through some calculator skill with you. Okay, the function I give you is fx equals to square root 1 minus x. Okay, according to the steps we go through last lesson, so to find the inverse function of this fx, what's the first step? Find domain of f. So number 1, domain of f. What's the domain of f? What's the domain of f? Everyone think about it. Which, like, left hand side is negative infinity and right hand side is 1 inclusive. Well, if you can't see it, we need to solve 1 minus x greater or equals to 0 and then 1 greater or equals to x. So x is actually needs to be smaller or equals to 1. So it's negative infinity to 1. Okay, you should be able to find the domain for the square root. Okay, second is, what's the range of f? 0 to infinity. Well, if you think about the shape of the graph, the endpoints must be 1, 0. And because it's a negative x but a positive square root, it will be reflected in the y-axis. So it's a graph looks like this. So you will have negative infinity to 1 as the domain and 0 to infinity as the range. Okay, number 3, what's the third step? What's step number 3 to find inverse? Swap that. So x equals to square root 1 minus y. And number 4 will rearrange. So what y equals to? Well, we can go step by step. What's the first step we should do? Square both sides. X squared equals to 1 minus y. And yeah, so minus x squared plus 1. So I have a quadratic or 1 minus x squared. Okay, what's number 5? Domain of inverse. Okay, domain of f inverse. What's that? Where, what to what? 0 to infinity. And number 6 is the range for f inverse. So what's range for f inverse? Negative infinity to 1. Okay, so the f inverse, I'll write in function notation. It got 0 to infinity, mapping to r, comma, f inverse x equals to minus x squared plus 1. It's very hard to sketch it on the same set of axes if you want to draw the scale right. So what I want to do is show this on the calculator. Okay, show this on the calculator. We go to graph. Okay, the first function is square root 1 minus x. Wrong place. 1 minus x. Okay, that's my first function. Let's say that's the graph. Okay, and then if, okay, nothing on top now. I want to enter another function. I need to press the tab button. Tab. Okay, T-A-B. Press that. You will have the second function, where to put the second function. So the next function, what I want is minus x squared plus 1. Okay, but we have a restriction, right? We have a restriction on domain. It's not the maximum domain. The domain is 0 to infinity. Okay, so I want to only show part of the graph. How we can achieve that is press the control and equal to find the bar here. Okay, it's control and then equal. We have this vertical line here. Okay, and then we say, what is my x? My x is greater or equals to, is that the same place? Control equal. My x is greater or equals to 0. Okay, this can restrict the domain. Okay, this bar is called like I'm restricting the domain now, and then put whatever like you need for the x. And I'll press enter. Can you see the graph? Well, I can move this to here and move this to here. I can't, like, can you see where's the intersection? Did you see it? Like about the first quadrant, right? That's where the intersects. So I want to see it more clear. Like it's the graph is too, like showing too much. I just want to focus on the intersection bit. So what I can do, I can go menu number 4, window settings. I want to change window settings here. I want to only show the bit I want. So, well, I can restrict the x minimum as like, for example, -1. And the x maximum as a 2. I want to restrict the area into the first quadrant. And then y value is the same. Well, I can show from -1 to 2 as well. This is just a guessing, okay, random guess. It should be around that area. Okay, can you see now it shows more of this, like more close to this area?
Can you just zoom in?
You can zoom in, but like sometimes when you zoom in, you not zoom into the place you want. I never really use the zoom in function. Like it will zoom in as what the calculator wants, and not necessarily that's the part what you want. So what I want to zoom in is manually do it. Yeah.
How do you do it?
Menu for 1. Menu and 4 and number 1. And then you change the x, y, maximum and minimum. It shows you a graph which is more close to this area. And then how many intersections you can see? Okay, is it on the line y equals x? Can you see the other 2 intersections? Is it on the line y equals x? No. Okay, so what I give you the statement is the wrong statement. Okay, so I can say when fx and f inverse x, they intersect, at least one of the intersection will be on the line y equals x. Well, if they intersect, they must intersect at least one point on there. But I can't tell the others. Okay, there are 3 points of intersections. One of that must be on the line y equals x. The other 2 I can't tell. But I'll tell you why they will intersect outside the line y equals x. It feels like it's not really make sense, but I'll show you why. Also, if I was to find intersection, well, it's a lot to talk about in the calculator page here. So in the calculator page, I can show the intersections directly, but the problem is the intersection will not give you exact values. Okay, what it will give you is decimals. Okay, and also how many decimals you want to see, it depends on the setting. If you go for menu and then go for the setting, this is the setting for the graph. Okay, the setting for the graph. There's another setting for the calculator page. So they're separate place. So you go to the setting, display digit. I make a float 7. So it's about, you can see 7 significant figure. Well, you can treat it as like about 7 decimal places. It's not really 7 decimal places. It's 7, I think it's 7 significant figures, so including the integers in the front as well. But like you can change, you don't really know what that means, but you can change to a higher level, which you can show more decimals. If say I want to see 4 decimals, you need to at least give like 6 decimals. I need to see at least 6 decimals to see whether like it's right, like to give proper rounding. And also the angle you put in radian form. After we learn circular function, it needs to keep in the radian form, not the degree, because that's quite important for VC study. And the graphing and geometric angle, you don't need to care about that. You just put in the degree, doesn't matter. And after you change it, move it. You change it to make default. Like when you make default, when you shut down the cache, when you reopen it, that will still be the same as the setting you have before. So it's not going to go back to the original setting. So if you press OK, I think sometimes you will go back to the previous setting. So make default to save the setting. And now I want to see the intersection. So 3 intersections. I can see on the graph. So analyze graph and go for intersections. Okay, there's a line, you can move it by use the left and right button. So I can find the first intersection there. So I will make my lower bound here to the left, or anywhere to the left. And then only include the intersection in. Do not include the next intersection, just finish at the first intersection. So the 2 lines, you press enter to make the lower bound, and then move it to the right, and then enter to make the upper bound to include the intersection in it, and you can see the intersection. That's 0, 1. Okay, let's do again. Analyze graph and the intersections. Now I want to look for this one. Can you see x, y value are the same, but the problem is it's not the exact value. That's the problem to see things from the graphing page. Well, I'll tell you how to make it exact later, but that's what you can see. Well, I'm just showing you that this is the intercepts on the line y equals to x. And then we have a last one. That one is 1, 0. Okay, that's the 1, 0. That's the intersection. So I have 3 intersections. 1 is on the line y equals x. The other 2 is AB and BA form. Okay, it's AB and BA form. So this question show you, I think 90% of the teacher, when they teach inverse function, they will say it will only intersect on the line y equals to x, but it's actually not true. It is true for 99% of the time. Okay, it's true for 99% of the time. This is a very special case. I will tell you why we can intersect not on the line y equals to x. But it's very rare, but that's one example. So the statement is actually wrong. It's not going to intersect only on the line y equals to x. There's other possibility also can intersect at some other place. But if they intersect, there will be definitely one point of intersection on the line y equals to x. Okay, so if they intersect, yes, you will definitely find one on that line, but you may also find other point of intersections. And also, this must be in pairs, okay, in pairs, except the one on the y equals to x, the other 2 must in pairs. You won't have 2 intersections, okay, you won't have 2 points of intersection unless those 2 are both on the line y equals to x. If one is not on the line y equals to x, then there must be another pair matching it. So it's not going to be like one on the line and one not on the line. That's not working. Also, how we can find the exact values. Okay, remember this function is with a name now. This root 1 minus x is called f1x. Okay, called f1x. This name is given when you're sketching it. And this one is called f2x, right? f2x. Remember that, and then we go back to the calculator page. So I'm looking for intersections. So in algebra way, what you do to solve intersection? Yeah, simultaneous, equalize them. So y equals to root 1 minus x and y equals to 1 minus x squared. We also equalize those. I can go menu number 3 algebra and number 1 solve. We want to solve for intersection. Solve for root 1 minus x equals to 1 minus x squared. But instead of typing that in, to save some time, we know the function y is already called f1 bracket x. Can you see the color is different? It's highlight ones. That's with already stored, it's got the memory. They know f1x is root 1 minus x. If you keep sketching graph, you will be f3, f4, f5. You will never have repeated functions. So your f1x refers to square root 1 minus x. And you can say that equals to f2x. Okay, those 2 equal. Instead of typing it again, I can directly make them equal and say comma x. Okay, comma x. Press enter. Oh, wait, there's more. Wait, can we see the sign, which means you missing some value. Let me see what's wrong with it. When you see this, you need to be careful because it means you're missing some value. I think it's because I restrict the domain here and that caused the problem. If I'm not restricting the domain. Okay, that show you the full solution. Because the problem is at F2 I restrict domain and sometimes you do some weird things when you restrict the domain. So I just type it in. But I'm just telling you, when you type F1x and you press enter, that should give you the same function here. You just like you got memories, okay, you got memories. So also, for example, you want to look for the y-intercepts. You want to look for the y-intercepts of this function F1x. What you can do, you can go, okay, copy that, drag it down, and change the x to 0. That's when x equals to 0. See what is the y value, and that gives you 1. And also, you can drag it down and change that to like any value, for example, 5. I want to see, that's not real, no, out of domain, -5, negative infinity to 1. So it can give you root 6. So this can sub-value directly. You don't need to keep typing the function again and again. This is called the define the function. You can define it and then easily change things there. Okay, come back to what we find for intersections. Can you see x equals to 0 and x equals to 1? That's the two intersections, 0, 1, and 1, 0. And also we have this one. Okay, so for example, if I don't know that intersection is on y equals to x, so I will copy that down because I can do highlight that and go Control C. Copy that, the same as it's like that laptop, and you can go Control V to do it. Also, okay, with my pen on the screen, I can easily highlight the part I need, but on your calculator, it's hard to achieve. So what you can do, you can make this arrow like this thing here, and then press the shift button. Is that shift? Yeah, press the shift button and go left, left, left. You can highlight that. I can't show this on my cast because my one can easily highlight it. But you hold the shift button. There's the shift button. See here? That's the shift button. You hold that and then press left, 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 left. It will highlight the part you need. So, and then you can also go shift right, 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 right to highlight the part on the right hand side. But my one is a little bit different. And when you highlight it, you can go Control C to copy the answer you want, okay, the value you want. And let's go down. I'll put F1x. Okay, I'll put F1. Okay, F1 something. Okay, F1 something. I want to see the y value. So I'll go Control V to change the x value in to see what's the value on that function. So that gives me the same thing, root 5 minus 1 over 2. So x, y are the same value, so that's on the line y equals to x. Okay, so that's just some skills in the calculator. What else? You can also define the function. For example, I have a function square root 1 minus x plus 2. Okay, I can call this function f3x. Okay, a new function f3x. So I can go Control and VAR to make an arrow here. Okay, Control and VAR. Control is here. VAR is on top of 9. And then you go f3 bracket x. Okay, can you see the f3 and the f1 before looks different? This is without define, still like in this form. And you press enter. It will say done. So now we will see f3x. Now like it looks different. So you have saved the function as f3. The name of that function is f3. So f3 refers to square root minus x plus 2. And now I want to see the intersection. I can say y-intercept. So f3 0, and I can enter. That will give you root 2. Okay, that will give you root 2. There's a lot of things you can just quickly do it. And there's one thing which is not really a calculation thing. For example, you type a really long function. Okay, you type a really long function and you have some mistake at the very beginning. Okay, for example, I have, well, maybe it's not that long, but okay. For example, that one. I have typed this in already and at the very beginning I have a mistake. I can go Control and 7 to make this thing directly jump to the front, and you can easily change things like in the front. You don't need to type 10 times of the left button to change it. And if you go Control and 1, you can jump back to the end, and you can change things in the end. So this is helpful when you go for year 12, and there will be some long expressions. And if you can use that properly, that can help you in some way. It's not really some great functions, but like it's just make your life a little bit easier when you want to change things. Well, if it's in the middle, can't help. Okay, can't go to jump to the middle. So at the front or back. Also, when you do the question, last question in the test, there's 3 simultaneous equations you're trying to solve for that one. You can go menu 3-1. You're still trying to solve for something, solve for simultaneous equations. And there's a button on the right-hand side of 9. Can you see here on the right-hand side of 9? You click on that. There's the last row. This one is a curly bracket, gives you as many equations you want to put in. So we click on that. So we have 3 simultaneous equations. We want a 3. If you have 4, you put a 4. And then you press OK. Now you have like 3 places to put 3 equations. After you put in 3 equations, you move the arrow like to the back, still in the bracket, okay, to the back. And then you press comma A, comma B, comma C, which is like the 3 variables you're trying to find. And then press enter like to solve for it. Okay, that's the 3 places to put equations. And then in the middle, you put comma A, comma B, and comma C. That's 3 equations you can solve directly by using calculators. And also, maybe it's a bit too early to talk about that. Well, if you want to solve an equation, menu 3-1, and after we, for example, want to solve x squared equals to x minus 2, comma x. Okay, I want to solve for that. It's not working, so how about plus 2? Oh, the wrong direction. It's a plus. Yeah, I can have 2 solutions here, right? You can see 2. But for example, I have a restriction on the domain. My x can only be greater than 0. For example, you have a restriction on your domain. I only want to see the solution when x greater than 0. So I will do the same thing. Okay, I'll do the same thing to solve for it. But I'll go Control equal to have this bar here to restrict my domain. I can restrict after the bracket, okay? It's not in the bracket. If you restrict it in the bracket, it's not working. You must go outside of the bracket to put this bar here and say my x is greater than 0. And that only shows one solution, which is the 2. That's the solution you want. Okay, you can restrict it before you solve it. What else? Couple of setting things. Okay, in the setting here, home page, go for document setting number 2. That's the float I talk about. That's how many decimals you will have. Okay, that's how many decimals you will have. You can see the fixed decimals, but I'm not going to talk about that this year. It's a little bit too early to talk about now. Like I'll talk about the second semester. But we put a float 10 or 12, make it larger. You can see more decimals. But there's only one problem to it. The problem is sometimes the calculator still, like a machine, still needs to work, right? Work out things. When you solve some really complex equation, like really complex one, and you want a lot of decimals, the calculator can become really slow and then may stuck in between. Okay, so it's just not working. It will stop working and say keep like turning there, like there will be a clock keep turning. Well, if you go back to the calculator, you can press, there's a button, you press to restart it. If it's stuck, you can restart that. Use like a needle or a pen to put on that. You can restart it if it's stuck sometime. But the problem is if you still, you restart it and still trying to solve the same function, there's a danger still stuck because it's just too hard for the calculator to solve it when you want a lot of decimals. So in this case, what you can do is you go for setting to change the setting to a lower level, like a float 5 or float 2, which allow the calculator to easily calculate it out and it won't stuck anymore. Okay, so that's something needs to be aware of. But for the normal function, like what we do now, like it's no problem with a higher float. Also, the angle radian needs to be in radians, like the unit, and not degree, because we will learn mostly radians in method. Well, if you learn further, that's another story. It will be all in degree. So you need to keep changing between the version. But this will cause a big problem if you not get it right. And the third, not the third one, the fourth one, no, fifth one, the calculation mode, this one, recommend you to put in auto instead of exact. Well, recommend you to put in auto instead of exact. Okay, what auto means? Auto means the answer what you get, it depends on what you input. Okay, if your input is decimals, a simple example, that's auto, right? I'll press cancel because I haven't changed anything. Go for the current. Okay, I want to solve for, let's solve for 0.7 divided by 3. Okay, 0.7 divided by 3. I want to calculate this. Well, you know, like this is not a divisible number, right? And my answer will be 0.233. It's not giving me the exact. It gives me the decimal. Why is like that? Because I put 0.7. Okay, because I put a decimal, it will tend to give me a decimal. But if I change it to 7/10 divided by 3, that will give me fraction. Okay, that totally depends on what you have put in. So if you put decimal, the calculator will give you decimals. If you put in exact form, that will give you exact. But not all the number can be expressed in fraction. For example, irrational number. Not all the number will give you exact values. That's why we put things in auto. When the calculator have no choice, it can't express things in fraction. It will give you decimals. But the problem with the exact is always want to give your exact values, but sometimes you just can't give your exact values. For example, irrational numbers. Then the calculator say false, I can't solve for it because you asked me to give me exact, give your exact, but I can't. So I'll say I can't solve it. So that's why auto is kind of a protection system. You depends on what you input, and the calculator will adjust the answer. But at the same time, when you have some answer cannot put in exact, it will also give you the decimals as well. Okay, I hope that explains why I should put that in this way. Also, control and enter will give you decimals always. If you go control and enter, that will always show you the decimal solutions. I think that's pretty much all you need for the basic function for calculators. When I meet more, like I'll talk about more about it. So, well, if you can remember all of it, it's quite useful for year 11 study already. Okay, so come back to, well, that's a lot of things. Come back to this question here. So this is the investigation question here. So the answer will be no, like to this statement. It's not going to only intersect on the line y equals x. It also intersects some other place. But I will tell you why it's like this. Okay, show you why it's not going to intersect only on the line y equals x. For example, I have a function fx. And I have this inverse function f inverse x. Okay, I have coordinates a comma b here, and also have a coordinates b comma a on the y equals fx. Okay, so if you have a point a b on the fx, what's the point you will have on the inverse? ba. So if I have ba on the inverse, what do you have on the original? On the inverse, AB. So can you see those two and those two will definitely intersect because in the fx you got a pair of coordinates already in the reflection of the line y equals x. So AB and BA both exist in the function fx. So same as this question here, 1, 0 and 0, 1. That's just a point which will be reflected in the line y equals x to become each other. So that's why when you swap the coordinates, you will still have the same two coordinates, and those two places are the place where they intersect. That's why I said if they intersect outside y equals x, that must be in pairs. So that's why they are a pair. When you have the inverse, you have another pair, and they are the same pair. So that's why they intersect outside y equals x. Is it clear? Okay, that's a lot to talk about. Also, give you a quick formula. That's if you have f inverse x, that will equals to f inverse fx and that just equals to x. So if you put the function fx into the original function, or you put the original function into its inverse function, that will just be x. Okay, that will just be x. But you need to talk about that more in year 12 with proper domain. Okay, with proper domain. This, I can't talk about that because we haven't learned composite function yet. But when you talk about composite function, there will be some restriction on the domain, but that is always x. Okay, that always equals to x. But what is the x needs to be investigated more. Like the x can take what values that needs to be investigated more. But f inverse x or f inverse fx, that's just equals to x. Okay, just equals to x. Okay, next question. Do I have enough time? Okay, so I can go through that one. Let's sketch the graph x over 3 squared with the domain 3 to 6 first on this grid first. Give yours 1 minute to sketch for it with the proper domain and draw that graph. Where's the turning point? If it's a full domain, where's the turning point for that graph? It's not that hard. 0, 0. That's 1 on 9x squared. Okay, that's just 0, 0. So it's a graph looks like this. Okay, turning point will just be 0, 0. So you can quickly see what the graph actually looks like. And turning point is not included in the domain. Okay, turning point is not included in the domain. Okay, that should be what the graph looks like. You need to care about the endpoint. Okay, we sub 3 in, that's 1. We sub 6 in, that's 4. So you have 3, 1, and 6, 4. Well, if you extend it, that will be a graph looks like this. Okay, so that's the full graph, but I only want the part from 3 to 6. Okay, let's do this. Step number 1 is the domain. What's the domain of f? 3 to 6. Okay, what's the range of f? 1 to 4. Okay, now I want to be careful. This question is very important. Number 3 will be swap xy. So we have what x equals to 1 on 9 y squared. Number 4 will be rearranged. So y squared equals to 9x. Okay, question is what is y equals to? Plus minus 3 root x was root 9x. So 9 can come out. So you need to have plus minus. Okay, you need to have plus minus. That's a square here. When you take the square root, even power, you must have the plus minus. Questions? Okay, if no, I can't take both. I can't take both. I can't decide yet now. Okay, I can't decide yet. That's why I need step number 6. That's why I said I need this like in quadratic equation. So let's keep going with that. Number 5 will be the domain for f inverse. What is it? 1 to 4. And the number 6 is the range of f inverse. What's that? Okay, let's use the range to think about the positive or minus. Which one I should take? Should I take positive or negative? Think about the range. If you take a negative, what's going to happen? Y is always going to be negative, right? It's not satisfies 3 to 6. So therefore, F inverse x needs to be positive 3 root x, not the negative. You need to write plus minus there, and then you decide after you find your range. You need to give a reason, okay? So just according to y squared equals to 9x, my y can be plus or minus root 3 root x. But I need to decide which one I want to take. So therefore, I can only tell that when I know my range. Because the range is a positive range always, you can't have a value negative. So you will have the positive 3 root x. So I will write F inverse x as 1 to 4 mapping to R. F inverse x equals to 3 root x. And okay, let's sketch for it. Okay, if I have a point, well, this is the fx. Okay, if I have a point 3, 1 on the original graph, so what's the inverse should be? 1, 3. Okay, if I have 6, 4, what I should have? 4, 6. And also it's symmetrical about this line. Okay, better sketch out the y equals to x. That's the y equals to x. So I know this graph should look like this. It's more flat. Okay, so something like this. No, I can't draw it symmetrical. Okay, that's better. So this is the F inverse x. Well, more point will help you better, but it just roughly working. Okay, that's better. So it's symmetrical about this line y equals to x, and you can see there's no intersection. It's not going to always have intersections. You're not going to always have intersections. Okay, let's think about the domain. Okay, my question is, let's think about the, yeah. You better sketch it because it's just see the symmetrical. But when you find intersections, you better sketch it out. But like if you don't have intersection, it's not really the whether you mark it. Like it's not a mark. This is not worth a mark. Let's have a think about the domain. Okay, do you know why we need to restrict the domain? Why I can't take R? Why I can't say domains R? Well, let's say, can I say find the inverse function for R mapping to RFX? It's not a one-to-one function. Okay, it's not a one-to-one function. So you can see 1 on 9 x squared is not a one-to-one function. So it's a many-to-one function. What's the largest possible domain you can take? What they take now is from here to here. That's the part of the graph they take. It's still one-to-one. What's the largest possible graph you can take? 0 to infinity or? That's right. So which means you can only from anywhere to left reach the turning point, and then from turning point to reach infinity. Or I can take any part which not include the turning point. Okay, which not include the turning point. For example, -5 to -2. Okay, -5 to 0. Okay, I can't go over, I can't beyond turning point. I can't make my turning point in the middle, because if I include my turning point in the middle, that will become a many-to-one function. Okay, so that's why we need to restrict the domain, and that's how we restrict it. There will be some question regarding to this. We can see later in the next page. So that's the maximum domain. So the maximum domain will be from infinity reach the turning point, and from turning point to infinity. So do not make your turning point in between the domain. Okay, let's have a look at the next question here. Yes. Okay, quickly see the next one. F -4 to 0, fx equals to x minus 1 squared plus 4. Well, find inverse. Let's sketch this graph first. On the grid below. So if you can think about that, where's the turning point? 1, 4. So I may not have it. So the part of graph it take is from -4 to 0. Okay, is the left hand side. -4 to 0 is this bit. You want to see the full pictures and then decide which the part you want. So we sub -4 minus 5 squared, 25. 25 plus 4, 29. Okay, -2, -6, 29, which is here. And 0, 0, 5. It's really difficult to sketch. Okay, that's -4, 29, and you have this point as 0 and 5. Let's go for that. What's domain of f? -4 to 0. And what's the range? 5 to 29. Number 3, we swap x and y. We swap x and y. And then number 4, we'll rearrange it. So y minus 1 squared equals to x minus 4. Okay, what y minus 1 equals to? Plus minus square root x minus 4. And therefore y will be 1 plus minus square root x minus 4. Again, it can't be plus minus. I need to decide which one I want to take. But we leave it here first. And number 5, what's the domain of f inverse? 5 to 29. And what's the range for f inverse? -4 to 0. So my f inverse x, I should take positive or negative? Negative? We should take negative. You can see the answer is 0 and less than 0. So if you take the plus, okay, let's say if we take the plus, the square root is always going to give you a positive number. And then you plus that by 1. So it's always a number greater than 1. But what you need now, you need some number less than 1. Okay, so only the negative will achieve that for you. So you're not going to be the plus. Okay, it needs to be 1 subtract something. Okay, 1 subtract something, not 1 plus something. So you want a range of -4 to 0, which is a value below 1. So you want to make it smaller. So 1 needs to subtract with the square root. Also, you can get this, I think. This is the left-hand side branch of the square root function, right? The left-hand side. So that will be take the negative. And then this is the positive branch. You take the positive. But I'm not sure. I haven't really tried this. I should investigate on this. If you have the negative quadratic, what it will look like? Okay, the negative x squared plus 1. I'm not sure if it's the other way, like the flip way. So it's better to see from the range to discuss that. other than remember the rule. Like it's too much to remember. But like if you analyze it, it will be easier. So I want the range less than 0. So I must go 1 minus something, not 1 plus something. So function notation, F inverse will give you a domain of 5 to 29, mapping to R, comma, F inverse X equals to 1 minus square root X minus 4. Okay, because we have a 0, 5, this is the F inverse X. That's the fx. So if I have 0, 5, I will definitely have 5, 0, which is here. If I have -4, 29, I will have 29, -4, which is here. Also, you know that's a cube root, so the graph looks like this. Some of the students I see, they draw like this, which is wrong direction. Okay, it should be this direction here. Because it's a square root. Square root only has 4 directions, okay? You need to pick one. So that will be this one here. So go that way. Also, I can't see any intersection here. Okay, one more thing to talk about. Well, first question is really easy. It says which one of the following cannot be the intersection. This question is not really correct, because as I explained, every point can be possible if like you include A, B, and B, A in the same graph. But like according to what we think, like for 99% of the time, D is the point like which cannot be included in the for intersections, because all the other points got the same x and y values, which is on the line y equals x. They will definitely intersect. So the only possible one which may not be intersects is at -a and a. But as I said, if you have -a and a negative a in the fx for those 2 points, they will still intersect. Okay, they will still intersect at that point. But anyway, this is think about the 99% of the time. So D will be the solution which cannot intersect, which is not really accurate to say in that way. But anyway, the important thing is example 2. Okay, this is help you to understand. For year 11, inverse function will focus on quadratic because that's the only harder function you learned, and then is you have the plus minus you need to talk about, and there's restrict domain you need to think about. So let's have a think. If A and B are real constants, for what relationship between A and B will this function have an inverse? As I said, if you want the inverse, that's a quadratic, right? X squared plus 2bx, that's the quadratic. Have a think. If you want to have inverse, it first needs to be a one-to-one function, right? A one-to-one function. How a quadratic, what's the largest possible domain for a quadratic to have the inverse? To -infinity to turning point, or turning point to infinity. But not necessary to reach turning point. It can be turning point or smaller, right? It can be not reaching the turning point. So you have a quadratic. That's too bad. That's the quadratic. That's the turning point. Not really reach the turning point. I can take from -infinity to here. Well, smaller than the turning point, but you can't go beyond than the turning point. Okay, can't go beyond than the turning point. So the important thing for this question will be find the turning point. Okay, find the turning point. How we can find the turning point for this question? Sorry, what is it? x minus, no, I think it's minus b over 2a, the formula we talked about for turning point. I can complete square, okay, easily complete square. I can see the turning point. Do not try to remember a lot of formulas, like you can just confuse with a lot of terms. So I don't really like students to remember a lot of formulas. Rather than remember formulas, you can remember the reasoning, like why we do that. So minus b over 2a is the result from completing square as well. So we can just quickly complete the square for that one. We have x squared plus 2bx and plus b squared and minus b squared plus half of the middle term squared and minus half of the middle term squared. And I have x plus b squared minus b squared. So what's the turning point? What's the turning point? Negative b and negative b squared. Okay, negative b and negative b squared. So this turning point is negative b squared here. Well, which is definitely something below the axis. Well, I have a graph like this. This point will be negative b squared. But it definitely will go below the x-axis because negative b squared is a negative number, so it's definitely there. But I can't tell minus b is a positive or negative number. I don't know whether b is positive or negative. But anyway, that doesn't matter. What I want to see here is what the relationship between a and b. Okay, you know your a maximum can take minus b, right? The maximum value a can take is minus b. So a needs to be less than or equals to minus b. So the relationship can be a plus b less than or equals to 0. Or you can keep your answer like this, be a less than or equals to minus b. Because the domain you want to include, you can reach, but you can't go beyond than the turning point. So the value of a needs to be on the left-hand side of negative b. So your negative b is here. Your a can only be those values. Okay, those values is the value of a. So a needs to be less than or equals to negative b. So you have a plus b less than or equals to 0. So that's the relationship between a and b to make this fx has an inverse function. Yeah, only have 7 minutes left. I'll just spend the last 7 minutes to finish up that, and tomorrow you can just do a revision lesson. I don't need to teach tomorrow then. So just squeeze this last exercise in that. Well, Friday last period, you don't want to listen what I'm talking about. So we'll finish up the last question here. A is less than or equals to minus b.
Oh, wait.
Okay, everyone. Last 5 minutes. Okay, a piece of rectangular cupboard has dimension of 18 times 24. Well, that's very quick. This question is easy. Well, it's not a rectangular. Okay, 18 times 24. 4 squares, each x by x centimeters, are cut from the corners. Well, you know, like the question, you want to make a box. You cut that. You cut that, which is x. And now you want to fold it in this way. Okay, so that disappeared, and you want to fold it up. This length will be 24 minus 2x. that length will be 18 minus 2x, and the height will be x. Okay, here will be x. So an open box is formed by folding up like that way. Find the function of v, which gives the volume of the box in terms of x. Well, it's not something difficult. The length is 24 minus 2x, the width will be 18 minus 2x, and the height will just be x. So length times width times height will give you the volume of the box. You can, if you can't see it, you can cut it like tonight. Like you can really see it. Also, you can expand that by calculators as well. Just quickly go through that. Algebra and expand. Bracket 24 minus 2x times 18 minus 2x. Well, not 3. And times x. Well, you will have this one. Okay, 24 minus 2x times 18 minus 2x and times by x. You will have this equation here. 4x cubed minus 84x squared plus 432x. That's the expanding form. Well, you can expand by hand as well. But the key thing is state the domain of this function. Okay, if you think about the domain, this is the practical domain. Okay, the implied domain to this function will be R. Okay, it will be true for any value of x. But to think about the practical domain, you need to know that's the length, that's the width, that's the height. What you need is 3 inequality function. You need 24 minus 2x greater than 0, 18 minus 2x to be greater than 0, and x needs to be greater than 0 simultaneously. Because you need to have some length, needs to have some width, and needs to have some height. Okay, so what you can solve for that one is x less than 12. What you can solve for that one is x less than 9. And what you can solve here is x greater than 0 for 3 inequalities. Okay, so you want to have some length, your x needs to be less than 12. You want some width, your x needs to be less than 9. And you want some height, your x needs to be greater than 0. In this case, we need the intersection between the 3 inequality. So as I showed you before, if you use 0, 9, and 12 to do this, what you need for x less than 12, open circle here, use a pink line, we have x less than 12. Less than 9, we can use another color, open circle here, less than 9. Also need another one which is greater than 0, open circle here, go to that way. You want the place which your x got 3 color, okay, got 3 colors, which is in between 0 to 9. Okay, but not including 0, not including 9, because you can't, okay, no color for this here. So x belongs to 0 to 9 exclusive. 0 to 9 exclusive. That's the domain for this function. You can't cut too much. Well, the width is 18. You need to cut from both sides. If you cut 9, just disappear, like the 18 disappear. Okay, you don't have any width now. Like for the 12, you can't cut 12, like more than 12. So we need to take the smaller one, so we can't go over the 9. We want to maintain the width. Okay, that's the end of chapter 4 and 5.
Yes!
Yay!